Hi there, you're in the lab with your mate JJ. Today is Maxitronix project today. Today we keeping on with our Sensor Robot 20. This is project 20 that we're up to, the final project. So today we do our last project for the 20-in-1. I'll do another video, a follow-up video concluding the series. But today we'll do the 20th project. The project will be weather indicator. Project number 20 is going to be the weather indicator. So we're going to jump on the computer together and have a look at the instructions. Once that's done, we're going to go over to the booth and we're going to assemble the circuit. Once that's done, we'll bring it over to the bench and we'll have a look at how it behaves under the thermal cam, under the oscilloscope, and so on. So first things first, let's jump over to the computer and have a look at the instructions. Here on the computer, just fire up our web browser here. Now, the instructions are here. As I said, this is the 20th project, the final project. Let's fire up the instructions here. Okay, this is project 20, weather indicator. What it does, this project uses the CDS cell and the touch board. The CDS cell senses how bright the sky is, then it turns the LEDs on or off to tell you if the sky is sunny or cloudy. The touch board senses the rain and warns you by means of the buzzer. The LEDs flash faster when it is brighter. When the sky is cloudy, the lights flash slowly. How it works. When it begins to rain, a drop of water on the touch board causes current to flow in the parallel connection of the 100 kilo ohm resistor and the variable resistor in your control. The current continues to the base of Q5, which is also connected to the touch board. Transistors Q5 and Q6 turn on. When Q5 is on, the output of the Astable multivibrator goes to the base of Q6. Then Q6 operates and the buzzer sounds. When the sky is clear and bright, the resistance of the CDS cell drops and the voltage between the positive side of the 47 microfarad capacitor and the cell increases. The voltage between the 33 kilo ohm resistor and the cell rises, thereby charging the 10 microfarad capacitors. Then, the turn-on time is reduced until Q1 and Q2 are turned on. The LED on time speeds up. If little direct sun hits the CDS cell, the LEDs flash more slowly. This happens because the resistance of the cell rises and the voltage between the 47 microfarad capacitor and the CDS cell falls. Okay. Looks to me like there's two Astable multivibrators in this circuit. There's this one here and this one here. Very cool. Alright, well, we'll pop over to the booth and we'll put this together. Here on the booth. So first things first, take the wires out of the previous circuit, so we'll do that. So that's all the cables out. Now we'll put the new ones in. Alright, we're done. Look, we used nearly all of our wires. We only have 3 left. So this is certainly the most involved project, which is suitable given that it's the final one. So let's pop over to the bench and have a look at how it behaves. here on the bench. So I'm just going to fire up our power supply. That's okay. The LED on that thing's a bit flaky. Anyway, looks like it's working now. So let's wire up our power supply. We'll make sure we get the polarity right. It's negative on that side and positive on this side. Now, the thing turned off. This is going to beep at us, and we'll switch out the beeper for the LED, and we'll use the green LED because the red LEDs here will also be in use. So first things first, let's power it up, and then we'll throw the switch here. Now, I'm expecting the alarm to go off. The alarm is controlled by the touch sensor, so let's install that. Touch sensor here and here. Alright, now let's touch the touch sensor and adjust the resistor. It's not changing anything. Oop, there it goes. Alright. So what we're going to do is just power this guy off temporarily, and we're going to switch out the buzzer for the LED. So we'll put positive lead here and the negative lead here. So hopefully if we turn that on, we'll get some oh no, that's not right at all. Alright, sorry. You know, really what we should do is get some banana plugs to DuPont female, and then we'll be able to just plug the thing in properly. So let's do that. So, have we got banana plugs to DuPont female? I suppose we do. Yes, we do. Over here. Alright. They're a bit stuck. We'll get there. There we go. There we go. Alright, so that's positive and negative. So let's put that on. Now I can never think through the polarity, so I just try it one way, and if it doesn't work I try it the other way. Alright, so we'll put our LED there. Oh, we've got it hooked up to, yeah, green. Green is good. Alright, so we'll pop him in there and him in there. Let's see how we go. So let's throw the switch, and it's on, but only a little bit. Oh, gee, I'm a goose. I'm such a goose. You know what I've just done is I've plugged the yeah, oh dear. So just ignore me. There was no way that was ever going to work. Alright. Well, let's put our touch sensor back in. And let's just take this off here and put it here. We have to take both of them. Alright. And now let's wire our circuit, which is here. Let's put with the positive on this side, and we'll put the negative on this side, and we'll just try putting that here and here. Now we turn it on and we're not getting anything through our sensor, so we'll switch the polarity into our LED and let's try again. Ah, surprising. Oop. I was expecting that to work. Why is that not working? That's not working, is it? Not working at all. Oh, maybe just because it's not. No. There we go. Alright, so if we give that sensor a good touch, then the LED, the green LED goes right on. And if we dry it up a bit, it goes down. So yep, if we dry it out, it goes down quite a lot. We touch it, it goes up. Okay. Now, of course, this was supposed to be detecting rain, not wet fingers, but that's good enough. So the touch sensor is certainly working. Now the light sensor, the CDS cell's right in the middle there. Now it should be the case that if we make it dark, it'll change the yeah, right. So if we cover it up, it blinks more rapidly. So if it's nice and bright, the LEDs blink very slowly. Look at that. I forgot to put the wedge in to take the glare off. Let me do that. Is that a bit better? Can you see that better? Yeah, sorry about that. All right. So when the light's right on, the red LEDs blink pretty slowly, and if we even just take the light away, they speed up a bit, and if we cover it, they speed right up until they get so fast that they turn off for some reason. I don't understand that. Does anyone understand that? When we cover up the CDS cell, it gets really fast and then off it goes. And it comes back if you remove your finger. I wonder if we close that and we yeah, so these circuits are actually quite distinct. Yeah, so that one's working different to that one. So yeah, that's interesting that that if it flashes too much, it goes off. I would have thought it'd just appear that they were both solid on. So I don't really understand that. We can do it reliably though. Take the finger away and it comes back. Fascinating. If you understand that behavior, I'd be happy to hear from you in the comments section. Now there's going to be two oscillators on this circuit, and the way we like to look at the oscillator is the base, isn't it? No, the collector on the output. Okay, so what we're going to do to look at the sorry, what am I trying to say? To look at the multivibrators, there's two Astable multivibrators in this circuit. we're going to look at the signal that arrives on the base of Q6, which is the one that controls the green LED, and then we're going to look at let's say pin 37, which is one of the legs of the flashing LEDs. So let's do pin 64. It's the base of Q6. That's over here, pin 64. So we're going to hook up pin 64 to our oscilloscope, and then we're going to connect it to ground, and a suitable ground would be pin 48, which is over here, and we've got a little alligator lead for that. So let's hook that up there, and we'll just clip that on there. Now that oscillator is the one that controls the green LED up here. So if we just activate it by touching the touch sensor, that's the signal when it goes into the LED. Okay, so let me just well, I might as well put you right over to the thing. No, I better show you it here. Okay, so you can see the oscilloscope up the top there, and it's still got the frequency counter actually that we had on it from last time, from the previous project, so we don't need to add the frequency counter because it's already there. I'll show you just quickly. If you look here, bottom left hand corner, that's the frequency 1.58 kilohertz. So this is the signal that we see when we haven't engaged the output. Now what we're going to do is engage the output, and the green LED goes on, and you can see that the signal changes quite a bit. First of all, the magnitude collapses, and second of all, the frequency starts skipping around a bit. So that's a bit odd, isn't it? But you can only tell when you look at it under the scope. Otherwise, it appears to be working pretty much properly. And if we dry it out, in various states of dryness, the circuit works more or less. But anyway, when it's real dried out, it just gives you that that square wave that we're looking at now. Now the other signal to look at, we said we'd hook up to pin 37. Where is 37? It's the collector of Q2, yeah, which runs over to here. So let's try that. Oop, here is it. All right, and let's just auto calibrate our signal. I wasn't expecting that. Maybe we should hook. What have I done? 21. No, that's not working at all. Why not? What about if we just put it directly across the LED? I don't understand. That should I don't know why it doesn't give us a signal. is it naive of me to expect there to be a signal across this diode? I don't understand why I don't see a signal. Seems to be going up and down. Yeah, just nothing. So there we go. We've finally got something. I don't know why the auto tune doesn't work. The frequency's all over the place, isn't it? So I'm not sure what to tell you about that. It's a signal that the scope can't find itself. When I clicked auto, it wouldn't stick onto anything. What I did was I adjusted the trigger manually. I brought the trigger down sort of into the middle there, and that sort of seems to have worked, doesn't it? And oh. Yeah, I can't get it better than that. This will yeah. So I'm not sure what to tell you about that. The frequency is jumping all over the place. If you look at the measurement, it's going from like 30 hertz up to like 180 hertz. So yeah, I'm not sure what to tell you about this. It's surprising. It's certainly not particularly regular, that's for sure. Anyway, that's the two signals out of the Astable multivibrators. So we've got to do the thermals now. So let's pop you over to the thermal cam, which is here, and we can see all the bits getting hot. All the bits getting hot. Let's get myself out of the picture there so I'm not affecting it. And let's move him across a little bit so you can see everything. Alright. Well, what can we see? Oh, that's interesting. Oh no, that must just be warm because my hand touched it. That CDS cell is actually getting warm. Isn't that interesting? Yeah, very interesting. And you can see all the resistors in the bottom left there. They're all getting quite warm. I suppose if we engage this circuit here, I'll just move my hand behind. No, I'll bring it down here. There we go. We keep that engaged. You can see that the resistor on the LED board up there. That's warming up a bit as well. There's a resistor over here that's a bit warm. And that's interesting to see that CDS cell, isn't it? It's radiating warmth out in a circular sort of thing. You can see it in the middle, just there. Okay, that's pretty interesting. And the other bits and pieces, you can just sort of see reflected heat around the circuit there. This is all the big actions down here with the Astable multivibrator that's driving the green LED. All right. Well, I think that concludes project number 20. We're done. So I'll throw you over to the farewell cam and we'll wrap up. And that's a wrap. Wow. So we made it. We made it to the end of our Sensor Robot 20. So I'll do a separate video concluding this project. But this was the final project. It made pretty extensive use of the board. I think it put all of the transistors into service, all of the capacitors into service, all of the resistors into service. The only thing it didn't use was the integrated circuit and the magnetic reed switch and the key. So it was a pretty extensive circuit. It certainly worked. So the red LEDs flash depending on how light it is. The lighter it is, the slower they flash. And we put the green LED in place of the buzzer, which sounded when the touch board got activated by moisture. So yeah, both of those circuits worked. I have to say we got pretty dodgy readings when we looked under the oscilloscope at the two Astable multivibrators. They weren't giving good reliable signals at all, but that kind of didn't matter because they were fit for purpose. They were good enough for their function, which was really just to drive the oscillating LEDs and to drive the tone through the buzzer. So the fact that they weren't a good quality signal with a regular frequency and so on sort of didn't matter, because that was beyond their pay grade to deliver that kind of a signal. But we saw it as it is, I guess, and it was a bit of a mess. I was certainly surprised that the oscilloscope couldn't auto-tune the flashing LEDs. I would have thought it had picked that up for sure. And when we automatically tuned it, we did pick it up. So I don't understand why we could do it manually and get a fairly stable signal, but we couldn't do it automatically. I don't know. Yeah, we did the thermals. The thermals were pretty much as expected. I was a little bit surprised to see the CDS cell getting warm, but it is a resistor, so it does make sense that it would. Yeah, there you go. So that's everything for Project 20. There will be a concluding video. I'm going to record a conclusion. I'm going to go over the projects and just talk about them. So that video will be coming out soon. But for now, that's all of the projects for the Sensor Robot 20. So after we do the concluding video, I'll do the introduction of the 30in1, which will be our next project kit that we'll be working through. So hope you enjoyed this video. Thanks very much for watching, and please remember to hit like and subscribe.